Problem number 37, we're asked to find the derivative of the inverse cosecant of a function, or the arc cosecant of a function. So let's get to work. First, let's start by inverting. Remember, if y equals the inverse cosecant of something, that means that y is the angle whose cosecant is x squared. So you invert the x and the y's, invert the input and the output, and now we have a cosecant. We can differentiate now implicitly. The derivative of x squared is 2x. The derivative of cosecant of something, well, that's going to be the opposite of cosecant cotangent. And the chain rule says times the derivative of y, which is dy dx. Okay? Well, to get dy dx by itself, we're going to have to eliminate the cosecant of y from the right side and the cotangent of y from the right side. This might be a good time to switch back into sines and cosines to make our thought process a little smoother. We're used to dealing with sines and cosines. So we'll call this negative 1 over sine of y times cosine of y over sine of y. Dy dx. Now, what we're going to do is we're going to multiply both sides by the sine of y to get rid of the denominator of this part of the fraction. So we'll have 2x times the sine of y. Now what we're going to do is divide both sides by negative 1 to get rid of this part of the fraction. So that'll give us a negative 2x here. And we still have to get rid of this cosine and sine over here. So let's multiply both sides by sine. And let's divide both sides by cosine. And now dy dx is by itself. Okay. This doesn't match any of the options. So, or does it? Yes, it does. Remember that sine over cosine is the same thing as tangent. I thought we'd have to go back and draw a picture and get this in terms of x. But it wasn't as bad as it looked. This matches option letter B. Thank you for watching the video.